Good afternoon, everyone, and welcome to our brief webinar, Modernizing Analytics for Public Safety. My name is Jonathan Linchek, and I am the Director of Technology and Strategy for the Qlik Group. I've been in the analytics space for over 20 years as the Director of Public Sector for Cognos, the Field Technical CTO at IBM Business Analytics and Watson Analytics, and the North American Executive for SPSS. I joined Qlik this year to help drive their analytics group to better support public sector organizations. Qlik has been helping organizations use data to better understand their business for over 30 years. We serve as the public sector preferred partner for Qlik, the leading analytics and visualization tool in the market. We work with customers all over the country, from police departments to human services agencies to departments of transportation. Recently, we were selected as the analytics vendor for the Maryland Think project. Maryland Think is a $195 million federally funded technology platform that's meant to help transform Maryland's HHS systems to a cloud-based data repository. Qlik is going to help modernize Maryland's existing systems and processes to enable easy sharing of information across the different agency departments. This will allow agencies to communicate and share data and processes with the state and other municipalities. I mention this opportunity because of all the agencies that I work with, police departments have the largest challenges when it comes to integrating data. They have a need to not only look at information they collect, but view it alongside the data from school districts, from HHS agencies, from transportation agencies, from state and federal groups, and many other sources. In addition, police departments have to deal with the many challenging big data sources that have becoming more standard over the past 3 to 5 years, such as GPS data, telematics information, information about the daily weather patterns, video, audio, dash cams, police cams. There's all these different data sources that police have to now start to figure out how to deal with. And departments need to be able to tie all this information together, making it usable for both their internal users as well as their constituents, and publish the data up to federal agencies such as the FBI and the public. So today, I just want to walk you through a number of examples of how Qlik and Qlik can help you meet these challenges and help modernize your analytics platform. So I'm going to jump right ahead into a demonstration. And at first, I want to introduce you to the Qlik and Qlik environment because no technology is going to be good for a department unless it's easy to use, unless your users can very quickly come on and be successful with it. So with the Qlik environment, we like to talk about how really there's only two things that you need to know how to learn how to do in order to be successful and start to better analyze your information. So let me introduce those two things first before we move into some of the examples today. So what you're looking at right now on the screen is a visualization kind of showing some high-level metrics that are happening within our municipality's police department. I can see that over the past 10 years, there were almost 12,000 different crime incidents. I can see they were broken up into different types of incidents, from armed robbery to aggravated assault to vandalism. In the middle of the screen, I can see the geographic location of all these incidences, with the ability to drill in and out as much as I see fit. In the upper right, I kind of see a high-level description of what some of these different crime locations were. Did it occur at a house, at a school, on the sidewalk, in the street? And on the bottom right, we see a longitudinal trend showing how the number of crime incidents has changed over the years. So the software that we're working with here is called Qlik. And just as the name implies, the first thing that a user needs to know how to do in order to be successful with the Qlik environment is to know how to click on something. With Qlik, it's very unique in that everything is always interconnected. So if I'm looking at a visualization such as this, I could go ahead and click on anything on the screen and see the results change instantly for me. So for example, if I'm interested in only looking at narcotics crimes, I can just click on narcotics and everything else updates. So now I see there are about 1,350 incidences of narcotics issues, and I see those on the map and the rest of the visualization. If instead I wanted to look at fraud, I could simply click on fraud. I could click on vandalism. I could click on multiple different things, right? Very easy for a user just to see what they want to see, click on it, and have the visualization adjust appropriately. Just as easily, and really the second thing an end user needs to do in order to be successful, is how to deselect something or declick, if you will. While I was clicking on things in the upper black bar here, it's actually leaving breadcrumbs so I can at all times see what I'm looking at. So right now I'm looking at 4 of the 26 crime descriptions. If at any time I want to reset that filter and look at everything again, I can simply hit that X and everything will clean itself up for me. So, as you're a user and you jump into this system, you can't make a mistake. As I start to ask questions, show me crimes that occurred at schools and on sidewalks that were narcotics related. And maybe you want to focus on a very specific area of the city by simply drawing a circle around it with your mouse. You can start to really get down into the specifics of what's happening within your municipality. I also want to mention, as part of the introduction here, that we're using this visualization inside of a browser, inside of the Qlik environment. But just as easily, you could be publishing this information out to your constituents on your public website while keeping all that functionality and all that interactivity intact. So here's just a quick example that we made for the St. Paul Police Department, where you can go to the website, you can start to understand what's going on within their community. And if I see these exact same visualizations and I want to interact with them as a constituent or as someone who lives in St. Paul, it's the same type of thing. I can look at, say, show me the trend for boating laws over the past few years. Or even, I'm really only interested in the years of 2009 and 2010. So drill into those 2 years and show me what's happening there. So very easy, not only for the workers within the police department and your analysts and your detectives to utilize the Qlik environment, but also the people of the city themselves. So once you're kind of comfortable utilizing the Qlik environment, you can start to get in and ask questions and get answers to the things that you care about. For example, if I'm looking at the time trend here in the bottom right-hand side, I can see that, the crime in our city has been pretty consistent every year until recently. Way on the right-hand side of this trend, it appears that we're starting to have some peaks in the number of criminal incidences that have occurred. If I want to, like I showed earlier, I can just use my mouse to kind of select 2016 and the beginning of 2017 and start to zoom in and drill into that data. I could do this multiple times. So really, if I'm only interested in, the first 3 months of this year and December of last year, I can drill in. And now what you see is there absolutely has been an increase in the number of criminal instances recently. In fact, we have some days where there's quite a peak here. On March 20th, there were 22 individual instances that occurred. I can see that the majority of those were armed robberies. 7 of those on that day were armed robberies. And again, the map is zoomed in to show me just those specific instances. If I wanted to, focus on a specific precinct or a specific area of the city, again, I could kind of just draw a freehand circle around those and focus just on that area of our city. And I see that there were 10 of those instances. So now that I'm focused on one day and one specific area of our town, I could actually, again, drill in and start to understand what was happening that day with those criminal instances. So again, now we have a different visualization. And this is really where we start to look at those big data sources, right? Those kind of more difficult to deal with systems. Right? We're not talking about data that could easily be stored in a relational database. We're talking about a sound from our 911 calls that might be stored in Hadoop. We're talking about dash cam and body cams that we're actually streaming the video from our vendor. We see that there's weather information now on the screen, right? I can see at 6 a.m. on this day, it was actually thunderstorming and 53 degrees. Right? The reason that all these data sources are important is because a lot of them can be utilized to help predict crime. When we do analysis with a number of different departments across the country, we see that weather tends to be one of the biggest predictors of crime, more so than anything else. And the reason for that, right, is the criminals are just human beings like the rest of us. So if it's a thunderstorm outside, if it's freezing cold in a blizzard, a criminal is just as unlikely to go outside as a regular person, right? So you are going to see more crime, unfortunately, on nice days and on sunny days. In the upper left-hand corner, we're actually seeing the GPS locations of our officers or our patrol units at that specific time. So I can see at 6 a.m. on March 20th, vehicle 40 was right here within our city. Down below, I actually see the telematics of all these vehicles. So I can see things such as their average speed, their gas level, their oil level. And as I walk through the day, certain vehicles might have maintenance issues that are going to show up as well. So we can utilize this data for machine learning concepts such as predictive maintenance, where we're actually identifying the vehicles that you need to take out of service before they break down so that our officers in the fields don't have trouble, when they actually need to depend on those vehicles when they're involved with a suspect. So seeing all this information on one screen and integrated together at a certain timestamp makes this information extremely powerful. I can start to step through every 15 minutes of the day and actually understand, how our vehicles moved around the city, what criminal instances occurred, if there were trouble with specific vehicles, etc. So again, here's 6:45. Here I can see at 7 a.m. it got to be partly sunny out, and you can kind of see how these cars changed as the day went on. And not only are we plotting, the GPS locations of the vehicles, but from time to time, different incidences are going to occur, different events. For example, here at 6:15, if I start to zoom in, I can see that there was an incident here that occurred with vehicle 44. Vehicle 44 actually performed a traffic stop at this time. And if I wanted to, I could focus only on vehicle 44, and then I could turn on its specific dashboard cam from that incident. So, a lot of times we're using dashboard cams and we're thinking about them as live streaming events, but we can actually use them historically as well in environments like this to start to analyze after the fact what happened with this incident. Did the officer perform acceptably? Right? Were there issues that came up that we might need to address later on in court or with the media? Right? So by syncing this information together, not only do I watch the dash cam, but I can read the description of the call stop. I can see what officers were involved and understand really the entire situation of what was happening at the time. And allow me to, just segue briefly to how we can also utilize this information, right? So, a big issue with a lot of police departments now is how do we capture information and data on use of force incidences that occurred, right? If that officer who was having that traffic stop actually had to get physical with that suspect, if something occurred during that traffic stop that we need to analyze, we're actually capturing that information now based on the standard that's been published by the United States FBI, right? So we're using that FBI data model to capture everything that we can about those use of force incidences so that you can do some analysis of them as well. So in this case, I see that there were 12,000 use of force instances over the last 10 years. Almost 10,000 of those resulted in an injury. And I can see a lot of detail about them, not only the location of those instances, but what was the type of injury that the suspect incurred, what was the type of force used by that officer, what has happened in the past with those officers. We're capturing all that data. Allow me to draw your attention, to this circle graph on the left-hand side, right, where I'm looking at both officer ethnicity and suspect ethnicity at the same time. Obviously, this is an extremely sensitive issue right now for police departments, but one with a lot of media attention on it. So I can very quickly understand on the left-hand side in the dark red, what was the ethnicity of the officer involved in the use of force instance, and on the right-hand side, what was the ethnicity of the suspect themselves. And by hovering over this visualization, I can actually see what percentage of each incident was with each ethnicity. So for example, with African American officers, I very quickly see that about 50% of their use of force instances were with African American suspects. But if I take that filter off and maybe look at Caucasian officers, again, by following the bars and the ribbons, and based on how wide those ribbons are, that tells you the relative percentage of each of those instances against each of the individual ethnicities. So very easy and very quick for you as an analyst to understand what's happening in your department. And from there, you can even drill down, right? So if I'm looking at these use of force instances, I can see that our Lancaster precinct has had the most over the last few years at almost 11,000 or over 1,100. I could click on Lancaster and drill into it to then look at it at the squad level. So I can see that our squad number 1137 has had the most of any squad inside of Lancaster. Drilling into that, I can get down to the officer level, right? So I can follow these hierarchies up and down as needed to get to any level that I want. And if I do happen to find an officer such as this, badge number 51137, who's had 14 instances over the last few years, I could actually drill in to a 360-degree view of that officer and understand everything about them that I know. Right? So I understand, if they're ex-military, what certifications they have, what their rank is. I can see demographic information about the officer, their number of years of service. Like we kind of saw on the previous screen, I can break down the ethnicity and the gender of the individual suspects that they're involved in use of force instances with. I can see the number of complaints they've received, as well as how many of them have been found to be substantiated. And I can even step through each of the individual use of force instances, see the location of them, what type of incident it was, and what was the cause of the interaction with the suspect. So here, for example, in August of 2006, they had a physical altercation in a routine patrol. In April of 2007, there was a firearm incident. There was an incident with mace. It looks like in May of that same year. So I could actually span through each of these on a timeline to really understand what's going on with this specific officer, and if we need to maybe provide them some additional training or do some other type of investigation into the situations that they're part of. So I apologize for that segue. I just wanted to kind of quickly go into the use of force applications that we've built. But back to kind of this big data view where I'm actually looking at the different vehicles over time. I could actually zoom out and instead of looking at that specific traffic stop, maybe I'm more interested in some more serious events that have occurred throughout the day. If I move forward in time to 6:45 and maybe up to 7, we can start to see some other things that are occurring within our municipality at the time. Here I see at 7 a.m., for example, on the left-hand side, I see that there was an armed robbery that occurred. And again, I could play that 911 tape, or I could read the description from that call log. In this case, this was a 911 call for an armed robbery at 301 Eastbrook Drive. It was a jewelry store, and witnesses describe a blue and white SUV leaving the scene. So I see that there was a pretty serious incident that occurred within our city. Maybe I want to do some analysis about what occurred. My first step might be to use my map to draw a radius around the event to understand which of my police vehicles were in the area. So I can see I actually had 2 officers within 1.5K of the specific crime as it occurred. And I could focus on those specific officers. Now, Qlik has built into it a number of geospatial capabilities to do some advanced analysis. And one of those is the ability to do real-time travel radiuses based on traffic patterns and what's going on at that time of day. So if I want to, I can ask myself, okay, at 7 a.m. on this day when this crime was occurring, how far could these 2 vehicles have driven within 5 minutes? And I can start to see, hey, were these officers well positioned to respond to this crime? Do we need to start looking at where we're sending our officers throughout the day to better cover the city? Because as you well know, when you're in a car, if there's a large highway, you can certainly get pretty far, represented by this red line that's on the highway up here. But if you look at where this crime occurred and we start to zoom in, you see that because it was more of a residential area, this jewelry store was just outside of where these 2 cars could have driven within 5 minutes. So right there brings up some questions that we might want to answer, right? Do we need to position our police officers differently? Or do we have some very smart criminals here who are maybe doing some analysis and understand that, hey, there's a gap in the coverage that the city is offering with its police force? So you can start to get in that level of detail when you're looking at this information. Now, I might want to focus on one of these cars. So if I focus on vehicle 24, I can actually start to better understand what it did before and after this 911 call was called in. So at 7 a.m., I know that this vehicle was relatively close to the jewelry store robbery. If I move forward in time to 7:15 and move forward in time to 7:30, I actually see that this vehicle started to move away from the crime instead of moving towards the crime. And my telematics data show that for this vehicle, it actually had a low battery indicator that came on. So maybe that's what happened is, rather than call this person to the crime, he started to have some vehicle trouble, which required him to return to the garage. Again, if we were utilizing predictive maintenance machine learning before the fact, we could start to try to avoid situations like this and allow an officer such as this to respond to a crime instead of going back to the office. But even though this officer didn't respond to this crime and drive to the jewelry store, we can go back prior to when the crime occurred and start to ask ourselves things like, hey, it looks like he was actually pretty close to the jewelry store 15 minutes before the armed robbery occurred. Maybe he happened to pick up something on his dashboard cam prior to it getting called in and prior to it occurring that we can utilize for our investigation. So just like I did before, I now can come and run a timed synced video at 6:45 for this specific car and see what they saw 15 minutes before this jewelry store was robbed. And if we kind of wait on the video and we watch, we in fact do happen to see a blue and white SUV driving towards the jewelry store 15 minutes before the crime occurred. So you're not always going to get this lucky, and you're not always going to have, the exact video you need to solve crime, but this shows the potential power of this type of analysis, the ability to pull in this data from different data sources, sync it together so your analysts can respond to what they're seeing in real time. I can do my analysis, and if I see something like this occur, I can turn on the body cam and get the information that I need. And this is really just the first step in an analysis process, right? What I might also want to do is start using the data that I've collected to predict, the location of crime for the next day and the next week and the next month. So what I see here are the potential hotspots where we're predicting that it's likely that crime might occur over the next week. I can see, a number of places where there are hotspots throughout the city, and this could actually affect my deployment of those officers. If I overlay on top of these hotspots our planned deployments for tomorrow, I can see that we're relatively well covered by this hotspot at Longmeadow Road. But some of these places over, such as in Prince Place or in Cog Hill, aren't as well covered. Maybe I want these officers to move a little further south than normal so that we can try to cut off some of this crime before it occurs. And this ability to use, machine learning and predictive analytics can really apply to so many things within a typical police department. For example, what we're looking at here is real-time forecasting of crimes year over year, where your analysts can come in and say, okay, show me what the crime trend is likely to be for the rest of 2017. And it is interactive. So right now, while I'm forecasting out 7 months, I could actually make as long of a forecast as I wanted. If I wanted to come in and say forecast out 20 months, you can see that now we're forecasting crime into 2018. If instead of wanting to look at all crimes, but maybe focus on specific types of crimes, show me what burglaries are likely to look like over the next year, or drug crimes, or bicycle theft, whatever it is, right? You can actually bring in all that data that you've collected over the years and utilize it to help make better decisions for policing as you move forward. Another final example of the use of machine learning is the ability to do clustering analysis, right? What municipalities or which cities in our geographic area are most similar to each other? Which precincts are most similar to each other? Because that can encourage collaboration so that you start to work with those other geographies to try to cut off the types of crimes that you're seeing, right? Maybe a number of different zip codes within your city are very similar when it comes to opioid addiction. So you want those towns to work together on specific task force in order to address those issues. So here I can go ahead and, again, in real time, create as many clusters or segments of our municipalities as I want. Right? If I want to go ahead and see my different precincts clustered into 8 groups based on a specific type of crime or a specific type of area, I can do that in real time. So these are much more advanced machine learning type activities than probably most police departments are doing now. But with Qlik and Qlik, they're definitely possible, and we've implemented these in a number of different locations. So I hope those examples kind of gave you a good feel of what's possible with the Qlik and Qlik solution when it comes to predictive policing. We want to make all the data that you have much more valuable for you, allow you to bring it together and put it in the hands of the users that can actually use it to make better decisions to help the lives of your constituents. With that, we have about 5 minutes left, so allow me to pause and for any questions that we have. Okay, looking at the chat on the webinar, it looks like I do have 2 or 3 questions, so let me address those. The first question is, how does Qlik compare to other analytics solutions such as Tableau and Microsoft? So if you bear with me for a second, I think I have a slide on this. There we go. So before I joined the Qlik group, back when I was at IBM still, Qlik was involved in a pretty intensive evaluation. As I mentioned, Qlik's been around for over 30 years. But as they were starting to get into analytics and starting to focus on the public sector, they wanted to make sure they chose the right solution for their customers. They wanted to make sure that if they were going to go in and use Qlik's credibility in order to pitch an analysis solution, that it was the one most likely to make their customers successful. And depending on how well you know the business intelligence market, right, there are a lot of vendors out there, right? There's Qlik, there's IBM, there's Tableau, MicroStrategy, SAP, etc. And a lot of those are actually very strong tools, especially when they're put into place correctly at banks and at retail organizations and at big commercial organizations and companies. But just because a solution such as Tableau is strong, say, with a retail organization, doesn't mean that it's a great fit for public sector. So when Qlik did their evaluation, they not only looked at things such as performance and scalability and extensibility and mapping and mobile, but they also looked at how good of a fit it was for the public sector space. Is this something that can meet the needs of a police department that needs to deploy data out to its constituents? Right? Is this something that can be utilized by a workforce agency in order to help their constituents get back to work? Right? So Qlik did this pretty intensive evaluation, and Qlik came out on top in almost every single way. And it's not just Qlik's evaluation that kind of shows the power of Qlik. Other third-party analyst surveys, such as the BARC survey, which actually interviews customers to understand what the customers of these tools think, show that Qlik came out as one of the most powerful solutions on the market. The Butler survey is another one, right, where they kind of compared Qlik head-to-head to Tableau and Microsoft in order to understand that comparison. So you can have confidence that if you make a decision to go with Qlik, you are using a best-of-breed analysis environment for you. The second question is, how are these solutions deployed? Is this a cloud solution? So that's a very good question as well, especially here in 2017. So Qlik has had success deploying Qlik in a number of different ways. So you can certainly purchase the Qlik software and deploy it in an on-prem environment. And in fact, because of security concerns, most companies and most agencies are still deploying their analysis environments in an on-prem deployment model. And Qlik has a lot of experience helping agencies get up to speed quickly for low costs and as quick as possible. So certainly on-prem is still probably the #1 way people are deploying. That said, we are seeing more and more customers start to engage a hosted cloud model. So if you are utilizing Amazon AWS or Microsoft Azure or one of the other cloud providers, you can actually deploy Qlik in a hosted model on those hosted servers. And that's something that you can do yourself or that Qlik can engage in and actually run those hosted environments for you. So whichever approach you take, we can assist you. The final deployment model that's utilized is software as a service, and that is available as well. So if you want nothing to do with the hosting of the solution, you simply want to use it as a user, you can go ahead and use Qlik's software as a service model in order to access the solution. Looks like the final question we'll have time for here is, how do you contact us? And if you want to get the slides or other information. So let me just move to that slide. So go ahead and feel free to email me at any time. My email is jlinchek@qoplycg.com. With that, I want to thank you for spending 30 minutes of your lunch break with us. I hope you found the examples valuable. I look forward to having a chance to work with all of you. Thank you so much. Bye-bye.